All right, welcome back. We are WebD6201 in the winter 2022 semester at Durham, and it's week 3, part 1 of our broadcast and recording and session together. And this week, last week, what did we talk about? We talked about DOM manipulation. We did some of that. We talked about JavaScript events and different ways of writing functions. I talked about 3 ways of writing a function. You could write a name function. You could write a variable that points to a function, and you could run an anonymous function. Those are the 3 main ways. We talked about a little bit about variable scope, and we also deployed live to GitHub pages, which was kind of very interesting to do. So that's what we did all last week. This week, what are we doing? We're going to talk about what the heck ECMAScript is. What is that? A little bit of the evolution of JavaScript, a bit of history. I'm sorry. I know no one likes history, but this is actually good to understand. ECMAScript 5 syntax versus ECMAScript 6 syntax. What does OOP look like with ECMAScript 5 and 6? OOP being object-oriented programming. How do I split code over multiple files? We're going to create a contact class this week. We're going to be using local storage and session storage to kind of save our contacts. And we're going to be creating a small contact list page. That's going to happen on Friday, as well as what is this use strict directive we've heard about? What is this thing? Due this week, ICE3 is due Friday. Test number 1, if you haven't started it, please, it's a true, false, multiple choice type test that tests your knowledge about JavaScript, things we've talked about in class, and maybe some things we haven't, but it's open book, open internet, and you have 2 attempts. That is due on Saturday at midnight. Again, it was open and available on Monday. Also, this next week, Lab 1 is due, and if we look at our schedule for next week, we're going to be learning about jQuery. That's going to be something we're going to be talking about, how jQuery has changed and JavaScript has evolved, and that for the most part, we may not need jQuery anymore. We're also going to be releasing ICE4 and Lab 2, which is going to be due a few weeks after that. So that is the schedule for next week. You can see that next week is a big week in terms of marks because 17% of your grade is going to be kind of put together for next week. This week, you have your in-class exercise 3 plus your test 1. Test 1 is worth 7.5% of your final grade. So please make sure, take it seriously. It's not that crazy to do. And again, open book, open internet, multiple attempts, so you won't be too pressured. All right, that's our schedule so far. Let's move on to the evolution of JavaScript and what that is. So JavaScript grew out of a very simple language. At one point, again, the scuttlebutt is that it was created over a weekend, right? Where it was a very simple language. There was 2 forms, JScript and JavaScript. They were also playing around with the idea of calling it LiveScript. Again, kind of like that one a little bit more. It was first implemented for the use with Netscape Navigator. Woo! Netscape Navigator. Does anyone remember that one? Way back in the day. We're talking about 90s, all right, when that was done. So probably most of you will not remember, but I remember it. And it kind of was there to help us with client-side logic. So it kind of added some behavior to our pages and that kind of stuff. And then things started to evolve. In the mid-2000s, people wanted to shift away from making simple websites to web applications. And they thought, like, can we use JavaScript to be more than this? So they developed some libraries. And one of the first libraries that came out of that whole thought process was jQuery. It was there to make JavaScript easier and to add CSS capabilities or presentation capabilities that CSS didn't do at the time because it was only CSS 1 and it was morphing into CSS 2. So that's what was going on around that time frame. And there was continuous demand for better browsers. And so in 2008, right, so kind of like just near the end of 2008, Google released its Chrome browser, which was kind of a monumental event. It created it along with something called a fast just-in-time compiler or compiling engine, the V8 engine, which was an analogy to the V8 engine in cars, right? Again, not that many of them now, only in sports cars and in trucks mostly. But Google's V8 engine was much faster. And then it kind of made people think, hey, man, this is so fast. Our systems were getting faster too. Can I just not use JavaScript on the back end too as a server? And one of the challenges was that we had a lot of languages, back then, and we still have them now. We have HTML, CSS, JavaScript, PHP, SQL language, right? We have all those things. We also have other kinds of back-end languages, .NET, and a bunch of other stuff. And it's a big ecosystem to build web pages. I mean, you needed to know all of that stuff. Plus, you needed to deploy, if you're a Windows user, on Windows, you had to have an editor. That Windows application had to deploy maybe on Linux. So you had to know a little bit about Linux and probably also about Apache, right? Because that's where your server was running on. It was a lot of stuff to know, to produce or build your pages compared with C++ or C Sharp. You're done. C Sharp or C++, one of those two languages, and a SQL language, you're connecting to a database of some sort, and you're good. You're golden, right? I mean, I know I'm simplifying here, but the point is that it's like way easier. It was like far easier and more streamlined to build an actual application than to work on the web. And for the most part, web designers were getting lost. They were like, hey, I can design a page to make it look nice, but man, I suck at code. What can I do to make it better? JavaScript had to change. So this guy, Ryan Dahl, he was, kind of doing some research on non-blocking I/O, and he had an experiment that he called Node.js. And Node.js was JavaScript that would run on the back end, and it used JavaScript's native event system to create a non-blocking server. Very interesting. It also used a modular system where you could plug in additional functionality and scale up your JavaScript backend according to your needs. So very much better than, let's say, something like PHP, which was kind of an all-in-one. Either you had PHP working for the most part or you didn't, right? And PHP used threads, which was a lot different, execution threads, compared to JavaScript's single-threaded application. That was really different. Performance-wise, believe it or not, JavaScript and Node.js did better, far better than PHP, and we'll talk about that in a future video. Later on, or around the same time, another two guys, Dwight Merriman and Eliot Horowitz, they were looking to build their own scalable hosting solution in 2007. That plan kind of failed, but out of it came something called MongoDB, which was a database that was written purely in JavaScript, right? And it was written in C++ and in other languages, but the object itself, it created a database that would run in something that was very JavaScript-like. It used a JSON-like data model. So instead of using SQL, it was a NoSQL database, and it used documents instead of records. And it used collections instead of tables. And it was very cool. It came from the word humongous. And that was the second piece of the pie, right? We had the backend, Node.js, and we had modules, other modules that came out of it. The Node package manager delivered those modules, and one of them was called CommonJS, which eventually morphed into something called ExpressJS as middleware. So then we had Express, we had Node, and we had Mongo, and what was missing was a good front end. And so people were thinking, well, is there a way to make the front end better, more reactive, more available for different kinds of devices? Mobile devices were getting more popular, and the mobile browsers were getting more, especially with the iPhone, the birth of the iPhone in 2010, as well as other phones that came out around the same time. Right, Android phones were kind of doing the same thing. Their browsers, mobile browsers, were getting more powerful and quicker. They were thinking, is there a way we can make a front-end framework that doesn't just work for the desktop, but also works for tablets and browsers and mobile devices? So they thought about this, and some companies got together to develop front-end frameworks, and there was a bunch of them at the time. But two big giants got together, Google and Microsoft, and they thought, you know what, we want to build out our infrastructure online. Let's create a project, an open source project called Angularjs, that we can write together. And it was one of the first times they really worked together, Google and Microsoft, to create Angular. So what is Angularjs? And it actually is still up there today. This is the newer version, but the old version was called AngularJS. And AngularJS started out 1.0. And one of the challenges with AngularJS is it was changing constantly. Great thing about AngularJS, it uses something called two-way data binding. And it was built on top of of jQuery again. jQuery was kind of like the foundational library that a lot of people use as a springboard, right? So that was something that was interesting. And so Angular depended on jQuery for it to have its, kind of responsive nature, for it to be adaptive to different screen sizes and so on. But there was issues. There was issues with code. There was the code became bigger and bigger, the code base, and more difficult to use. And at the same time, Microsoft was tasked with finding a better way of doing things. And so it created something called TypeScript. TypeScript was a library that was used, or a language, a brand new language, which is a superscript of TypeScript. And the reason why it was created was because of Angular. Angular was coming out, and it was difficult to diagnose problems. JavaScript notoriously was terrible at bug fixes and bug finding and debugging techniques. And they needed a better system that presented better tooling options than JavaScript provided. So TypeScript was born. And I'll tell you guys that TypeScript is like one of my favorite languages to use. And the reason why is because it makes JavaScript easier and superpowered. I'll tell you how it is. It's really great, and it makes it very clear how JavaScript fits into the entire picture. So they made TypeScript together, and they combined it into a brand new project that was based on the old AngularJS, and they called it Angular. Angular was made for developers by developers. It was the developer's dream, and so in some ways. Why? It uses a lot of different design patterns. It uses the observer pattern. It uses the command pattern. All the of those 23 design patterns that we may have discussed at the beginning of semester, it uses quite a few of them, which is pretty awesome. It's a mobile-first framework, and so it's made. So mobile devices are first-class citizens in this framework, and it uses a component-based architecture, which is very, very interesting. So again, you can see that it's using components. And what this allows us to do is reuse components across different applications or different parts of the application. We had consistency in look and feel and responsiveness, and you could reuse components, if you're, kind of developing new projects in the future, which is really awesome, right? So amazing tooling, really good speed and performance. And one of the things that AngularJS had, and even Angular later on, it was a single page application. So it didn't all update all at the same time. Only parts of the page would update when an update was required. So if I had a piece of data on the page, a table of some sort, when the data for that table updated, Angular would use something called two-way data binding to connect with the database and watch the database. This is going back to the observer pattern. It would observe the database changing, and then as soon as the data changed in the database, it would instantly update the page. So this idea of two-way data binding made Angular super powerful, right? And it also kind of described a different paradigm on how to set up its application infrastructure. And one of this thing was called MVC, Model View Controller, right? Where it separated concerns. It took the model or the schema for the database, and it created its own class and a way of connecting to the database. It had views, which were basically the presentation layer, right? And it described all of the pages that were going to be seen on the site, and controllers that were kind of the logic behind the views, and the logic that connected to the models that would eventually connect to the data and fetch the data from the database and deliver it to the view. So really, really cool way of doing stuff. But as you can hear from what I'm talking about, way more complex. They created a monster. And I mean that in a very nice way. I mean, it was awesome. Again, for developers by developers. But the learning curve, my friends, steep. So out of this came other front-end frameworks. Some people said, hey, we can do it a little bit easier than this. And one of the front-end frameworks that is probably the most popular right now is called React, right? So React.js, again, instead of being a framework, is a JavaScript library. Angular, super opinionated. And that means that you have to do things the Angular way in order for you to make things work, right? You have to use Angular for everything. You have an infrastructure, you have a way of setting things up, and you must follow that way. That's Angular, right? And it does things with TypeScript. You can do things with JavaScript, but TypeScript is preferred. React, it's a library. right? And it's component based, similar to what they do in Angular. However, you don't need TypeScript, and you use whatever piece of it you need to make things go, right? So less opinionated. There's still quite a bit of infrastructure from a setup perspective. You have to bootstrap, React in a certain way for it to work. But again, way less in terms of infrastructure. And then the other two that came out, one was called Vue.js, and we're going to talk about this later on. Vue.js is kind of, I would say, number 3 at this point. And one of the ones that is gaining popularity is called Svelte. Okay, that's kind of one that's out there right now. Svelte is even leaner than React or Vue, or way leaner than Angular. It's fast, it's simple, and it's pretty cool. Disadvantages of using Svelte compared to React is documentation and support. Otherwise, React would be number 1 now. I would say Angular would be number 2, and Vue would be number 3 in terms of popularity. All right, so we're going to talk more about this later on. So again, it supports also something called test-driven development, which is a different way of working. And we'll talk more about that. And it created this 3-tier web application architecture, MVC. Okay. Once we had those pieces in place, the front end, the back end, the database, and middleware, then we had this idea of this full stack, right? How to be a full stack developer or a solution stack, right? There's different kinds of solution stacks. The one that we're talking about here is called the mean stack. Nice little acronym. Mongo, Express, Angular, and Node. There's also the MERN stack. Mongo, Express, React, and Node, right? And there's also other stacks that are not JavaScript related. For example, an AMP stack, Apache, MySQL, and PHP. And there's different versions, flavors of the AMP stack. LAMP, Linux, Apache, MySQL, and PHP. Or WAMP, Windows, Apache, MySQL, and PHP. The .NET stack, where you have IIS on the back end, as an example. Maybe you're on an Azure cloud. You're running, ASP.NET or .NET Core right now is what the solution stack is. It's pretty cool. So there's a lot of different kinds of solution stacks, and each one of them could name you a full stack developer. But traditionally, a full stack developer, when I think of them, it's someone who knows how to program on the mean stack or the MERN stack. Okay. So that's the evolution of JavaScript in terms of that. Any questions around JavaScript, how it evolved, how it emerged, and where we are right now before we get into ECMAScript and what that is? So what is ECMAScript? ECMAScript is it's kind of like a standards organization. Let's take a look at that. So up online, if you look up ECMAScript, it takes you down to this organization right here. Let me just flash over to it. ECMAScript. So ECMA International, right, is, we can get information about ECMAScript here. And ECMAScript is like the foundation for, sorry, I'm getting a question from Matt online. Are you intending on still streaming on Friday for students who are unable to make it to class? Yes, I am. So ECMAScript, ECMA International, it creates the standards for all JavaScript and other languages as well. And right now we're at ECMAScript 2021, right? One thing you can do with this is you can view the standard online. So if you go to View in HTML, here is the international standard for JavaScript. So why is a body like this necessary? Well, back in the day, there was no control, right? It was kind of the Wild West of web development, right? And, there were some little fixes here and there, and things would, change fairly rapidly. They're still changing rapidly, but at least we have a standards organization to keep track of stuff. One thing to note is if you looked at if you scroll down here to the introduction area on the ECMAScript website, it tells you where it came out of. ECMAScript is based on several originating technologies, the most well-known being JavaScript from Netscape and JScript from Microsoft. That's where ECMAScript came from. And it talks about how it grew and what it does. The ECMAScript organization, or ECMA International, adds additional functionality year over year. So what happens is every year, typically around mid-year, June, July timeframe, we have a new version of ECMAScript that comes out, and it influences the API for JavaScript. ECMAScript started, or JavaScript started, with ECMAScript 3, kind of. There's actually previous versions of that as well. But ES3 was the kind of the crappy version of JavaScript that originally came out. ECMAScript 5 fixed a lot of issues. And as we approached HTML5 development, HTML and JavaScript were kind of developing at the same time, and so was CSS3. It kind of developed into HTML5, CSS3, and ECMAScript 6 all around 2015. That's when it happened. So we're looking back now 7 years as of this recording. And right now we have, we're at ECMAScript 2021. And why? Because the new standard of ECMAScript that is what everything that JavaScript is going to be coming up and changing mid-year this year in June, July timeframe of 2022. All right, so that's where it's coming. And what this does is it defines a bunch of new features and things that are deprecated from previous versions of JavaScript. Okay. Now, the great thing is you can support, your browser supports everything from ECMAScript 3 all the way to ECMAScript 2021 for the most part. Okay. So to see the stuff that your browser can support, a lot of times there's a great little site we can use, and it's called Can I Use? Okay, Can I Use? So let's take a look at that site. It looks like this, caniuse.com. And you can always go to this website and kind of access it and try and see what some of the stuff that are available. And it covers things like CSS features, HTML features, as well as JavaScript features that are available on most browsers. So if I was to look up something like ES6, then you can see that most browsers support ES6, ECMAScript 2015, ES6, and forward. You can see that that is supported by 94% or up to 96% of browsers globally. And you can see that all the browsers are listed here, i.e. Edge, Firefox, Chrome, and so on. Okay. And of course, these are the ones that are the most common, these ones right here. And you can see that they're fully supported in the most newest versions of Edge, Firefox, and Chrome, and Safari. Okay. So that means any things we talk about here, like the classes and all those kind of things we're going to be talking about today, they've got at least partial, if not full support. They say 95% is what they deem as full support from a spec, and anything that is less than that is considered to have partial support, right? Partial support. I kind of look at it like, okay, as long as your browser supports, or 90% of browsers support it, I think you're okay at this point. Anything less than 90%, 90%, you would have to be cautious. And I would say anything less than 80%, you should consider not using it. All right, because again, you're going to kind of hit some browsers, but not all other ones. Okay, it's really up to you. But remember, the lower this number is, a lot of times means that you'll have a smaller audience, and some of the features you want to pull off in your browser won't work properly in some browsers. So if, let's say, someone likes to use something like Safari, and you like to use Chrome, it's available in Chrome, but not in Safari. And you can see that there's stuff like that is here, right? All right, cool. So we're going to be talking about this website later on, okay? One of the things we're going to be looking for is the word class, right? So if I look at the word class, it tells you that ES6 classes, or anything from ES6 and beyond, is fully supported. So again, in my opinion, it's 90% support, and more than 90% support worldwide, okay? And if you look down, there's other features you might see that have very similar things, right? That you can see that they're more or less supported, okay? So static classes, as an example, so JavaScript classes, static, are only supported 90% globally, which is pretty cool, right? So that means you can use static classes as well. And you can see that, the extends keyword, that's also something that is 93%, supported, and so on. Okay, the constructor keyword, again, 93% supported. And I think this is why it's really great to take a look at some of these features and see what is supported and what's not. All right, so that is ECMAScript 2015. And it started with ECMAScript 3. It said, ECMAScript 3, ECMAScript 5, and then it went to ECMAScript 6, and they said, we're not going to call it ECMAScript 6, 7, 8 anymore. We're just going to name it by the year, 2015, 2016, and so on. So what it did was add additional features. And one of the things that we want to talk about is all ECMAScript 6 features and OOP. Let's start talking about OOP by taking a look at that website online for TypeScript. So let's go back to that TypeScript website. So again, to get to TypeScript, you want to go to typescriptlang.org. Please go there with me. And for typescriptlang.org, what we want to do is we want to go into the playground. So go into the playground. And if there's anything there, like I have some stuff there, just wipe it out. Okay. And we're going to start with some examples here. So remember what we do with TypeScript. TypeScript makes JavaScript easier in some ways. And we use it for larger applications and for tooling. Okay. It doesn't replace JavaScript. It is JavaScript and additional syntactic sugar to make JavaScript easier. Okay. That's what it is. So what we want to do here when we're in the playground is I want to go to tsconfig because I want to show you what it looks like when it was ECMAScript 5. We want to start with that. So in tsconfig, which is going to be our tsconfig.json file eventually, I want you to go to where it says target, and I want you to change the target from ECMAScript 2017 to ECMAScript 5. And I want you to change it out of JSX for React to none. It's going to reload. And I want you to get back there and remove ESNext as the module pattern and go back to CommonJS. Okay, that's what I want you to start with. So TypeScript, ECMAScript 5, JSX is none, and module pattern is CommonJS. I want you to scroll down and deselect all of these things. So deselect the declaration and ES module interop, strict mode, no implicit any, all this stuff. Just deselect all this stuff here. Okay. All this stuff. And what I want to do when we scroll down after we've done this is stripping away any features that TypeScript will give you when it emits JavaScript. So TypeScript is a compiled language, right? The way to convert TypeScript, which is we're going to put on the left, to JavaScript, which is going to be on the right eventually, is for us to transpile. When I think about transpiling, I always think about Star Trek. You know, beam me up, Scotty. Transpilation, transporting. And of course, the way it's going to work is we're going to transpile from TypeScript to JavaScript. First, we'll write our code. And currently, in all browsers, no browser supports TypeScript native. It doesn't support it, right? It supports JavaScript. So we have to convert our TypeScript into JavaScript. And you're going to say, wait, what? Why should I do that? That's an extra step. And yes, you pay for it up front. But what it does, here's the great advantages to using TypeScript. This is why Microsoft created TypeScript for Google to use for Angular, is because it gives us amazing tooling, guys. It also adds typing to JavaScript, which is great. And it allows us to structure our program, like we're used to. So example, if you come from a C# background, a Java background, or a C++ background, TypeScript makes it super easy for you to get into JavaScript right away. Let's talk about it and see what happens. So this is what a class would look like now. I'm going to type the word class. And as soon as I do, I get this emission. So TypeScript emits JavaScript. Take a look at this. What does this remind you of right here, guys? Right here, this part. From here and this part. Anyone? Here? What is this stuff that I'm talking about? Eden says an iffy. Yes, it is. Cooper also said an iffy, I'm pretty sure. So that's what it is, an iffy, right? And so when I want to make a class, okay, I gotta be honest. I didn't trick you guys, but I was kind of using an iffy from the very first moment of we were together because I knew we were going to come to this point. And you're going to look at this pattern and go, what the heck is this? Well, we know what it is. It's a self-executing anonymous function, or otherwise known as an immediately invoked function expression. And it runs right away. It calls itself. And what we can do is we can set up a name, a friendly name for this function, right? And it really becomes the name of the class. So if I want to make something that we've seen before, the person class, let's do it. We'll make the person class. And notice that the name suddenly becomes person, okay? And if I was to code the person class, just like you're used to, here are some things that we might include. Instance members, right? Instance members would be, or class variables. They're also called class variables, right? We're also going to have some kind of public properties, and private instance members, right? Because we want to support encapsulation, which is an OOP principle, right? So encapsulation says we want to have private instance members, fields, where we hold everything, and public properties. Those are our ambassadors. And these usually are getters and setters, or otherwise known as, accessors and mutators, right? That's what they are. And that's what we need. We also need some kind of constructor function, as well as, maybe some private methods, right? Or some public methods. We need all those things too. That's kind of how we lay out a class in C# or in C++. We just might do it slightly differently, or in Java. So in C# and Java, this is very understandable. We're talking about here, right? So let's add a constructor function. What does that look like in TypeScript? Well, it looks like this, constructor. And when I do the constructor function, it doesn't really make a difference here, but notice that there is something called a closure. We have the iffy, that's our closure. And inside that function, we have another function. This function here, my friends, is the constructor function. That's what it is, okay? And we can call this something different. Notice the name of the constructor function is the name of the variable that's been assigned to the anonymous self-executing function that is our iffy. These two things are the same. So this is kind of like, I always kind of look at our iffy as like the curly braces that surround the class. That's the iffy right here, right? And this constructor function is another function with the same name as the iffy. All right, that's what it is. So again, if we're making a person, maybe we want to take in some variables, right? And we can say, well, we want to have some kind of name, and we can specify the type. We can say string in TypeScript, and we can also specify another parameter, which is age, and we can specify another type in TypeScript, right? Notice on the right, we get the parameters, but no types, because JavaScript, it doesn't have types. It's loosely typed, right? Okay, cool. Nice. But I don't want to assign these things directly to properties. I want to create private instance members. Let's see how I can do that. So in TypeScript, we can say, I want to make a private instance member called m_name. We've been used to that kind of convention using C++ or C#. And we can say that that is a string. And we can also say that we have a m_age, which is a number. So we can have these private instance members. Notice here on the right, 0. We have none of that because we cannot declare things private. In JavaScript, any classes and any members that are inside that class are considered public, no matter what you do. You cannot make them private even if you wanted to. The only thing you can do to make them private is encapsulate them into another closure. That's it. All right. But for the most part, everything is public in JavaScript. But here we can have the private keyword. So you're going to be like, well, why do we need that, Tom? If everything is private in JavaScript, public in JavaScript, why do we need private in TypeScript? Because of code hinting, because of tooling, because we want to establish the same kind of structures that we're used to as C# and Java developers, right? Okay, cool. So we got this part. And so what do public properties look like? Well, they're getters and setters. We can do that. We can say something like get, and we can put the friendly name for the getter, which is name, right? And we can tell you what type it is. It's a string type. And of course, we're going to return the reference to this.m_name. Notice the keyword this. You cannot use this implicitly in TypeScript or JavaScript. You must use an explicit this reference. This refers to the class itself. Okay, so this refers to the class's member variable. All right. And again, that is a getter. If I only had a getter there, our property would be read only. Okay, so now we're going to setter or a mutator function. It's the same name. And we pass in a variable for that, which would be something like name. And we can explicitly say that this is a string. And we can say that this dot m underscore name is equal to the name parameter. And let's make it look nice. You can separate it or not. It's not really that finicky, but that's typically how you could do it. See that? Look at that. I kind of put an error here and TypeScript caught it. JavaScript, it doesn't matter. It wouldn't complain. It'd be hard to catch. That's why we use TypeScript, because of tooling. All right, cool. So copy this. Let's make the other one. So here's our extra property. So this one would be called, take a look, we're getting errors here, right? If you try to do this in JavaScript, it wouldn't complain at all. It would go, okay, fine. You want to make the same property again? No problem. With the same name again? No problem. Who cares? I liken it like this. You know, if you're a waiter and you want to serve meat to vegetarians, if your boss tells you to do that, you just do it. That's JavaScript. And TypeScript will go, like, whoa, 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 whoa. This is the wrong dish, guys. This isn't supposed to go to that table, right? And that's the beautiful thing about TypeScript. TypeScript will complain. TypeScript will say, there's something wrong. That's what we want. Even here, if I change the return type to a number, and I'm returning a string, it's going to say something is wrong. There's a type mismatch between what you're returning and what you're telling me you're supposed to return. So this is going to be m underscore h, right? And now there's a problem here because the setter doesn't match with the getter. That's a problem too. So this should be, instead of name, it should be age, and it should be of type number coming inbound, right? And then of course we're going to assign m underscore age to the age. There is no name. Look how it crossed it out. That's the kind of tooling I'm talking about. It says, hey, the type void is not assignable to type number, which means something is wrong here. Oh yeah, there is no name, it's an age. Cool. It's giving me some hinting, information about how this is going. Great, so this is fantastic, name and age. And we have our constructor function. Let's now use it like we normally do. We can say something like this dot name is equal to name, and this dot age is equal to age. And furthermore, we can have, we won't do a private method today, but we may have a public method, and the public method might look something like this. Public says hello, which returns void. And we can say that the says hello method outputs to the console and says something like, with a template string, it says, hey, this dot name, the person, right, says hello. Awesome. Okay. So now we have a class. And when we look on the left, we can say nice, nice, nice. Everything's nice. On the right, not nice. Oh my God. What is that? That's a monster that we have on the right. It's spaghetti code. It's something that is going to give me nightmares, right? Okay, maybe not nightmares, but let's try and understand what's happening here, right? Again, no types in JavaScript. That's one thing to note, right? And when TypeScript tries to convert the code we've written here, which is nice, nice, to something from ECMAScript 5, a throwback going back before 2015, right? It tries to convert this and it says, okay, cool. So we've got some things that are the same. This looks very similar to this. The only difference is that this says function and this says constructor, right? The only thing that other thing is there's no types, but otherwise this is the exact same. And you're going to say, wait a minute, if this is real JavaScript, how the heck do I have this dot name? And then we can say, well, take a look down here. We have the object super duper class, the class that makes all classes. This is the central class to all classes, the object class. And every language has something like this. We use the method called define property. And now we come to this weird thing right here. And you're like, wait, what? What the heck is this? Let's go back and to our drawing board for a second. Back in the day when we were learning how to program in OOP, we said that, hey, we have a super class or a base class or a parent class, right? And then we derived or extended this class and created this child class or derived class, right? And the child class or derived class is a specialized form of the superclass or the parent class, right? And it has an is-a relationship. We can say that the child is a parent, a form of the parent, right? But a more specialized one. We can clearly see just from the size of the boxes that the child classes are bigger. They're fatter than the parent classes. Why? We have a larger memory footprint. There's more stuff going on in the child compared to the parent. In real life, actually, it's the exact opposite. It's more like the parents are really fat and the children eventually become fat when they become parents. But, for now, it's mostly the parents that are fat. But in programming wise, it's more like this. It's more like the parent class is super slim, and you should keep it as slim as possible. And then when you add features to the child classes, they become bigger and even bigger when we inherit from a child that inherits from another child. And so here's the example. My person class is the parent. My student class is the child, right? The student class is bigger than the parent class because it has everything that the parent class had and then some. And then when we inherit from student and we make a specialized form of student, the domestic student or maybe international student as an example, then we're further specialized and it's even bigger. It has a bigger memory footprint. And this is great as an example for, classical inheritance. Guys, JavaScript is not classical inheritance. It uses something called prototypes, right? So it does things a lot differently. And what I want you to think about is this. When I have a prototype, I want to attach properties and functions to it. That's what I'm doing. Okay, so I have my object prototype and I make my person class. I'm actually creating a specialized form of my object prototype, but actually all I'm doing is attaching more stuff to my object. It's not the same in terms of the way inheritance works. And so when I look at anything that has prototype into it, in your mind, when we talk about prototypes, you should just replace prototype in your mind to make it easier with class. So we can say that, hey, I want to define a property on the person class, and that property is called name. That property is going to be done with something called object notation. Object notation is going to say, I want to create an object, and inside of that object, I want to define 4 properties: the get property, set property, enumerable property, and configurable property. The last 2, enumerable and configurable, are very close to real properties. They're Booleans, right? So enumerable is false and configurable is true. Enumerable means that can I iterate across it like an array or a collection? And configurable means can I modify it? Okay, so that's pretty cool. So I can modify this property, but I can't iterate through it. And then I have 2 other properties: a get variable that I assign an anonymous function that returns this dot name. And you're going to scream and say, wait, Tom, there is no such thing as this name. How can it return something that doesn't exist? Rule in JavaScript. Here's a rule. You assign it, you create it. If I assign something to an object, right, it's created, just like up here. I assign the parameter name to this thing here, it's created. If I didn't have all of this, it would make this anyway. That's what I'm telling you. The only thing that this does for me is it creates data members, this dot name, this dot m_name, right? It creates this. Why? Because of the setter function. The setter function basically says, hey, I'm assigning name to m_name. Let's make this thing. And we'll store it inside of the prototype. Okay. What does this mean? That means m_name is never private. It's public. Even though it looks private to us, it's still going to be accessible at the end of the day. Just FYI. Okay? Things that are different about JavaScript than they are about C# and Java. Number 1. Same thing goes here. When I say, hey, I want to define a property for the person class, and I want to call it age, and I want to do similar things. And then what about this public method here? Hey, I'm going to say, look, for the person class, attach, this is how you read this. For the person class, attach a says hello variable. I want you to point that variable to an anonymous function, right, that does this. So now, effectively, says hello is a function because I'm making it point to an anonymous function. Remember, this is the other way, one of the other ways of declaring functions in JavaScript. And I told you last week that this is more popular, believe it or not, than the named function wave that we've been using this whole time, right? Because of this relationship. Finally, we return person back out of this closure. Okay, well, now your brain must be busting and you're like, do I have to program like this? This is crazy. This is the ugliest thing that I've ever seen in my life. And the answer is, remember, this was ECMAScript 5. We've evolved. And so let's take a look. Let's change tsconfig to ECMAScript 2021, which is the latest version. And now it looks a little different. In fact, it looks almost identical to the TypeScript side. By the way, it wasn't like this before. Okay, when ECMAScript 6 came out, it wasn't as clean as this. Even getters and setters and everything else didn't look quite like this, and it wasn't supported at all. Really, ECMAScript 6 was not supported, so we needed TypeScript back in the day in 2015 when it came out, right? And when it was starting to be used, it came out before that, but in 2015 it really took off because we needed to have TypeScript work and create something like this, but we know instead of this on the back end, it used this. So this is what was on the back end, but on the front end, it was a beautiful way to work because we work with something like this. Okay, so that's what it was, right? So this is what we want to use here. This is what's going to happen. On the left, you can clearly see that we don't have things in TypeScript or JavaScript that we would want. We don't have type at all still. All right, that doesn't exist, right? So we don't have access levels. We can't do private and public. Even if I put public and private, it's really just for me in TypeScript. It's for me from a code hinting, code coloring, and tooling support. That's what TypeScript does for us. It makes it so that if you're a C# or Java developer, you can shift into creating programs for the web. And you know what? The shift isn't that great. Look, I guarantee you guys know almost everything you need to know to program to do OOP in TypeScript right now. Just the stuff I've shown you today. Okay, and that is amazing because before it wasn't something that we could do. There is a cost. Okay, there is an upfront cost to putting together TypeScript, to transpiling, to create a tsconfig.json file and all that stuff, but it's a one-time cost. And then afterwards, you have to remember to transpile. And there's ways around that too. Okay. Other things that are missing that we don't have in JavaScript is something called namespaces. Namespaces. This is great. And remember, rule, when we program in JavaScript or in any other language, classes should have their own file. Okay, good. Nice. But whenever I declare something like this, if I was going to use it, let's use this class. So again, we're in our playground, and we're going to say let's make a name up, Tom, right? Okay, Tom is of type person. We can say that. Take a look that comes up as a choice now, as a type. I made that type. I have to use the new keyword always in JavaScript. It's not an option like it was in C++, right? I must use the new keyword, and I'm going to say it's a new type person, and I'm going to get code hinting on what I want to create just by making it TypeScript. And of course, I can say something like, well, the name is Tom, and the age is not true. It's not true. But we can make something like this, right? And I would love for this to be the case, but it is what it is. You can't time travel. So, but then you can simply do something like this: Tom.says hello, right? And then this will call the method. So this is exactly what we would be expecting. And if I was to run it here in the browser, because you can do that in the playground, it'll come up with Tom says hello. Yay. Okay, that's what this does when we execute it. And if I click back on .js, we'll go back to this. So this is logs, this is .js. It's all up online. It's a great testing ground, guys. And the reason why is because you can test something out here before you code anything at all in Visual Studio Code. Amazing. Okay. So this is nice, but take a look. I just did it here. That means if I can do it down here in the same file, guess what? I can do this in the console. And I don't want it to be done in the console. If I can make a class in the console, that would be horrendous for security, right? This is a terrible security hole if we put this all in the console. So we want to encapsulate some of this in something called a namespace. Namespace. Does that exist inside of can I use? If I put something like, JavaScript namespace, is that a thing? And the answer is, nope, doesn't exist. There are modules. If I go module and, in can I use, it talks about importing and exporting, it has the module tag we talked about before, the ES6 module tag, which allows us to import and export. That exists, but it doesn't have a formal namespace. So what would a formal namespace look like? Let's show you what that looks like. So in TypeScript, what you could do is you can create a namespace. A namespace is like an enclosure for the class, right? So we can say namespace, just like you would in C# or C++, or it would be a package in Java, right? So we'd say namespace is, let's call it core. So there's our core namespace. Maybe they'll make it lowercase core, doesn't matter, core or core. Core looks like it's better because it's capitals, why not? And we can kind of put curly braces in there, right? On the right, you can see right now, we got nothing. There's no namespace here at all, right? But if I take this whole class, not including this part, and I cut it out, and I put it inside of the namespace here, then now, well, we have some stuff going on, right? You can see on the left, on the right, now we have another iffy. There's our iffy, and that is TypeScript solution for a namespace. It creates another iffy. And I have to tell you, there's a problem. Notice that here on the left, there's a little problem. There's a little red dot there. And that little red dot says, we got a problem. It says, cannot find name person. Why? Because person, the person class, is now encapsulated inside of this namespace. And notice how it's grayed out. It's grayed out because it can't be used. It's private. This is the only way you can really do private anything. Okay? Putting it inside of an iffy does it for us, right? To expose our person class that we can use it, we need to use the export keyword. What this does is it changes the iffy a little bit. What we do is we get a variable called core. We pass it as a parameter to the iffy itself. And then what we can do is at the bottom, we can attach a person property, right, to the, the iffy, the namespace. So we can say that person now exists in the namespace. Remember, when I assign it, I create it. That is this rule. I assign it, I create it. So where is this second person coming from? This second person is actually the constructing, the actual class, the class person. The class person is going to be assigned to the core namespace, and we're going to give it a property of person. I know it's confusing to say core person is equal to person, but what we're saying is go to the core namespace and add a person property and then assign the person class to it. That's what we're saying. Okay, nice. We have some other syntax we're going to go over on Friday. But then why do we still have an error here? Because we got to have to use the name of the namespace first, dot person, just like we would in C++ or in C# or in Java, right? The name of the namespace first and the person. And if this seems cumbersome, okay, it might be, but it's also way safer than putting our person class in the public namespace, or what we like to call the global namespace, which is part of the browser cache, right? That is not a good thing. So that is what we want to do. And unfortunately, that's another thing that's missing from JavaScript. There is no option for a namespace. We'd have to code it ugly like this. We know what an iffy is, so it's okay for us. But for the average web designer, they'll look at this and they'll pull out their hair. They don't know what this is, right? So again, I'm being facetious here. Forgive me, web designers, if you're watching this on YouTube. All right, but at the end of the day, that is how it works. And this is the way we want to make it go. Questions around namespaces, questions around the TypeScript, the way it's formed, and what it emits, which is JavaScript. One last thing before we leave this little playground, okay? I would always want in tsconfig to enable the option to, when it comes to type checking, please check on strict, and please check on always strict. What always strict does is it produces the use strict directive in our JavaScript. The use strict directive, the beautiful thing about the use strict directive is it tells JavaScript that you cannot add or declare a variable or use a variable without declaration. That's what use strict does. Because by default, guys, I'll let you know something. if you wanted to assign a variable, let's say, for example, I made a variable called my variable. I didn't use let, var, or const, and I said like my variable is equal to 5. It would allow you to do that. Okay. Cooper says, would you have multiple classes in core? Yes, we would. And what were the 2 config settings? The 2 config settings was, if I go to tsconfig, if you scroll down, there is a type checking. You want to check on strict, and you also want to check on always strict, those 2. Again, this is just to show you the use strict up here. One day, when we actually program our tsconfig.json file, we'll have a bunch of those configuration details laid out for you, and you'll be able to do it as well. So use strict is a directive we can use in JavaScript. We have to do it manually for us. It is a string that just has use space strict with a semicolon at the end. And the browser will look at this thing and say, okay, I cannot use a variable unless I declare it with a let, var, or const. Okay, and it's actually what it does is it reduces errors again. That's what it's for. All right, excellent. So that is the stuff that we want to go back to the PowerPoint with. So module pattern then, modules, there is a solution for ECMAScript 2015, 2016, and so on, all the way to 2021 for module pattern. And the way it's done is you have to enable the type module attribute for each module in as a script. Remember, one thing to note is, in order for me to attach a script to, that's a separate file, right, in our web development, I need to attach it to some kind of HTML document. Okay, let me say that again. If I want to attach a new script, I always have to attach that script to the HTML document. So if I have 5 scripts, that means I'm going to have 5 scripts at the bottom of the HTML document that I got to attach. If I write the scripts, it'll look like they're there, but they won't work because it's not part of the browser cache. The browser will not interpret anything that's not attached to it. Okay, so that's one thing to note. But they have another pattern that you can use as well. It's not a namespace pattern, but it's probably the second best thing in my opinion. And what it does is it does 2 things. It gives us 2 words, import and export. For the export keyword, what we can do is, first of all, we'd have to, again, set it up as a module. Let's suppose we have a separate file called lib.js, right? And inside that lib.js, we have a function called half of, right? Here's the half of function. If we put the export keyword in front of it, now we can expose that function outside of the lib.js file. And the way to do that is in another file, like let's say something like main.js or app.js, we can use the import keyword. We can import the name of the function from the file that we're getting it from that has this function exported, right? And we don't have to put the .js there. The .js can be dropped because when we're doing an import, we're going to assume that whatever we put in the single quotes after the from is a JS file, okay? So that's a way of doing it. We export something in lib.js, we prepare the function, and then we import it into another function, another file. So split files, right? And if I have multiple functions, I can import both of them. Import half of and multiply from whatever the thing is called, .js, right? So that is the 2 functions, the couple things we can do, right? We also have something called a default export function. And let's suppose I have an anonymous function. Here's an anonymous function. I can assign the export default to it. Let's suppose that I have that file only does one thing, right? It has a single use, if you will, right? And the only thing that file does is it does this anonymous function. If that's the case, then I can attach export default in front of it, and then that whole file is just going to do this function. That's what it does. So when I import it, I can say import, and I can call this whatever I want, this piece right here. And whatever I call this, it'll be representative. It's like a variable that will represent this anonymous function. So if I call this something like my function, right? Then instead of do something, I can just call my function. Okay, like this. Okay, so it's really depending on what we want to call it. But it's going to come from do something, the do something.js file. So another way of doing things. I'm pointing this out because at the end of the day, there's many ways to use this. And this module pattern is very common in ECMAScript 6. We're going to see it also in Node.js, which is coming up in the second half of the semester. Okay, so some more about that. And let's get into classes. Classes we've talked about. We've talked about how to make a constructor. One thing to note is that all classes have a toString method that we can override. And we're going to do that today, right? A couple other things to talk about. We're going to be talking about arrow functions now. So what the heck is an arrow function? And arrow functions are kind of a shorthand syntax, but in many ways, they're familiar to us from C# and Java, or even C++, as they look to us like lambda expressions or lambda functions. That's what they look like to us, right? And so what does this do? Well, it's kind of a shorthand. So the old way might have been to write a function that looks like this. Let's suppose I had an array that was called numbers, and I wanted to use the map function for the array of numbers. We would pass in an anonymous function with some kind of parameter n, and then I would return n times n. And I would map the numbers that I would have in with this function to return, the result would return a collection, a new collection, that's the map, and I would save it inside squares. Squares would now be the new collection that would have whatever the original function was, the original array, but squared. We can always write it like this now with the fat arrow function or the arrow function. You write a fat arrow, and the fat arrow replaces function, and the n, if I just wrote n fat arrow, then it would replace all of this. Oops, all of this. And if we kept going, and if I wrote it this way, it would replace the curly braces and everything else. So you don't even need the curly braces, and you don't need the return. It would just do this. Shorthand for all of this. So why? Why do we do that? Because a lot of people think that this is more meaningful in many ways than this, right? Because they don't understand anonymous functions. Also, one thing to note is if we use the fat arrow function, it retains this. It retains this. So sometimes what happens is in a closure like between these two curly braces, if I try and do a this dot something, it refers to this closure itself, this closure. This dot refers to this, not the class. Whereas if I did some kind of the same function, if I call the same function using arrow functions, it retained the closures this, right? Which is sometimes the way we want to do it. We could use, if I wanted to iterate across an array of numbers, I can use numbers.forEach and then a function like this. That's the old way. But the new way would just be to do this, numbers.forEach, and then we just do n fat arrow, and then what we're going to do in here. Okay. So kind of a neat way of doing stuff, very powerful. You're going to see arrow functions used all over the place in JavaScript. One other note about object notation. If I wanted to make a new object, I could do it in a couple ways. I could say const author is equal to new object, right? I could do that. Alternatively, I can just say const author is equal to curly braces. In JavaScript, curly braces is a new object, right? Eden says, how does it know to replace the function? That's just the syntax. So when it sees this, it knows what to do. Built in to that. So it kind of looks at this when it interprets this, and it converts it to this for the most part. All right. But what it also does is it retains the lexical this, right, from its parent function, whatever that parent function is. So if this is a function within a function, then sometimes we'd lose, like I said, we'd lose our context, and we'd have a second context in here, a second scope. And sometimes we don't mean to do that. We mean that if we had a this keyword in here, we mean it for the superclass or the parent function. We'll talk about that in a sec. So this is a couple ways of declaring an object. So way 1, and here's way 2, and here is way 3. Okay. So I can declare it as a new empty object with the object keyword. I can declare it as a new empty object with the curly braces here, or I can declare it as a completely made up object. Again, this is kind of like a live object. That's what this is like, where I can declare properties for everything, including an array, an empty array, a string, as well as a print books function, as an example, that are all part of the author object separated by commas. Or remember, when we assign it, it gets created. I could say I want to make a new empty object, right? And I want to assign a new property called full name, and I want to assign my name to it. Now full name exists because I've assigned it. When you assign it, you create it. Okay? Make sense? All right, so that is arrow functions and object notation. Let and const. We talked about let and const. I said, don't ever use the var keyword. It's terrible. Why? Because if I declare in a for loop, here's a for loop. If I declare the var keyword in a for loop and I declare I, guess what? This I variable is available in my entire scope. It escapes this scope right here. We think that the variable is going to live and die in here, right? That's what normal variables do when you put it in a for loop, but not so with var. No, sir. No. Once you declare this, it takes this var variable and it hoists it. It uses something called hoists it, and it puts it at the top of our code. And it does it when we're interpreting it with the browser. So the browser goes through and says, what's this function? Okay, do this. What's this for loop? Oh, I see. I'm declaring a variable. This variable's got to be in the global scope. So it takes I and puts it in the global scope. But now I is available here, everywhere. Guys, we never want to use this because this is error prone. Let, on the other hand, doesn't do that. It maintains scope. So it kind of, when you declare it here, it lives and dies in this area right here. That's what we expect, and that's why we want to use let and const and not var. Var bad, let good. Okay. Oh, one more thing. We kind of missed it back here. But I think there was this thing that you saw, and if you thought this was a typo, it's not. This triple equals. Okay, what does this triple equals mean? Does anyone know? There's equal, and triple equals. What is triple equals? It's actually a thing.
Isn't it something like the same data type as well?
Yes, it's actually the way you talk about this is it's exactly equal. If it's exactly equal, you're testing if it's exactly equal. If I use equal equals, then if I did something like this, if I said, is 2, right, equal to 2, this is true, right? This is true because 2 and 2 are equal. But if I said, because it doesn't matter if it's in a string or if it's the number 2, the literal 2, it doesn't matter. But if I put equal equals, right, that means that are these two the exact same type? Well, this is a number and this is a string, so the answer is no, so this would be false. And so guys, we want to use exactly equals as much as possible in JavaScript, not equal, exactly equals, 3 equals. And there's also variations for not exactly equal and greater than or equal, and so on. Take a look. All right, let's continue. So that's let and const. And default rest and spread, I'm going to let you guys read. It's just another set of methods. JavaScript closures, we're going to stop with our theory by stopping here. For JavaScript closures, one thing to note is this. A closure is when we have a function that contains another function. I'm simplifying it, okay? But that's what it is. So the parent function encloses or encapsulates, right, the child function. So here's our parent, and here's our child, and because our child is inside of our parent, right, then we can say that the child function is enclosed. Anything that happens with the child function does not escape the parent. We can call our child function from the parent, but we cannot call our child function outside the parent. If I tried to call child down here, it would error out because child is only available inside the parent. So this closure is exactly what we've been doing with our IFI, our immediately invoke function expression, right? Because our closure, right, as an example, is going to make this function private in many ways. Same thing with our message, const message hello world. This message is not available outside of the parent. It's only available in these curly braces, right? Because we're using const. If I use var, it would be available everywhere, right? That's what a closure looks like. So, but what happens if I return child If I return child out, then yes, then we can access it because parent returns child. So therefore I can get access to the child because when we use a return, we're exposing or exporting the child out from the parent. Okay. Cooper says, will this stuff be on test one? Some of it will. Okay. So parent-child relationships. Any questions around any of the things that we've talked about today? So that's kind of my kind of preamble about JavaScript and what JavaScript is, what ECMAScript is. You should know the difference now between JavaScript and ECMAScript. ECMAScript is a made from ECMA International. It's a body of standards that make up the JavaScript language, and it gets updated twice a year, usually on in June-July timeframe. Okay, and it increases or adds or removes features from JavaScript, the JavaScript language. Usually, it just keeps evolving JavaScript and adds more and more stuff. Okay, that's what it does, and that's ECMAScript. Okay, and JavaScript is a language that evolved from way back when Netscape Navigator was around, and it's a scripting language. It gets interpreted by the browser. We also talked about OOP and how that works in both ECMAScript 5 and before that, as well as how it works in ECMAScript 6 and after that, 2015, 2016, 2017, so on. Okay. Now, what I want to do is do a bit of a demo for the last part of our day. Let's go into our code and try some of this stuff out. So again, last time we had ICE1 and ICE2. I'm going to make a brand new folder inside of our section 3 folder. Our containing folder is section 3 that contains all this stuff. Let's make a brand new folder. So new folder. This is for ICE3. And what I want to do is I want to go into ICE2 and select everything. Control A, everything, select. But deselect my node modules folder. Copy everything, Control C. And go back into ICE3 and paste everything other than the node modules folder. So node modules not pasted. Okay. Then what I want to do is open up Visual Studio Code. And I want to go back into here and drag and drop my ICE3 folder into Visual Studio Code, just like we've done in the past. Okay. Let's add some things to make it different. So we want to go into our package.json and make sure this says ICE3. What it says something else like ICE2 or something else, change it, please. So we should keep this up to date. Next, if you have a README file, and we do, change this to ICE3. Okay, now that we've updated this to ICE3, let's open up a terminal, right? And you can use an integrated terminal in Visual Studio Code or an external one, a command prompt. And we want to type yarn install. Okay, that command. I'm going to put it inside of your chat. Yarn install. Okay, and maybe I'll do it for everybody else instead of just one person. Sorry about that. Yarn install. Thanks, Matt. And then what yarn install will do, no problem, when you do it, is it's going to install node modules. Hey, look at that. Node modules come up, but it's grayed out. It's grayed out because we have, hopefully it's not going to be put up online eventually. Right now it is, but eventually it won't be. So there's node modules, yarn install. Okay, great. And I want to put this up on GitHub, right? How do I do so? I'm going to say, going to go up a step. So cd space dot dot. So cd space dot dot. There we go, right? And we want to do, what we want to do here is we want to say git add dot, right? So that's the first step, git add dot. And then git commit -m for message. And we don't want to use initial commit. We've already done that. We're going to say added project files for ICE3. Okay, so git commit -m added project files for ICE3. Okay, I think I spelled it wrong. It's not sit, it's git. And then And then finally, you want to do a Git Push. And Git Push will push your files up on GitHub. So Git Push. Now, why is it doing this? Because in our Git, we have a git ignore file, and the git ignore file ignores node modules. Okay, just FYI, right? And I forgot to save everything. That's okay, but that means we're going to have to save our package.json later on. Notice that's a modification. So I talked about how it's a bad idea not to have node modules, right? When it comes to our the stuff that's online. If I want to push this to durhamprogrammer.github.io to make our live site, but remember, I can always copy all of this in the operating system if I wanted to. I can copy all of this, including node modules, and pop it into my durhamprogrammer.github.io, and we'd be okay. We don't have to worry because node module is already there. Okay. Now, if I change something, definitely I want to overwrite node modules. So what I may do is just wipe this whole thing out. Other than the git, the hidden.git file, I wouldn't do that. The hidden.git folder. I would just copy everything in except for this. And then when I push it up to GitHub for our live site, I would have everything, including node modules. But locally, we don't have to do that. Right? Okay, so that's kind of a way of doing things slightly different. Good. We've done all this work. And now the next piece. I want to create a contact class this week, right? So I'm going to do that in the scripts folder. Remember, we're going to make a separate file, one class, one file. So we're going to right click and I'm going to make a new file. We're going to call this contact.js. And we're going to start with the class keyword, contact. And what we're going to do here is let's put it together like normal. We want some public properties. We can't do private instance variables because JavaScript native doesn't support that. So public properties first, which means our getters and setters. We want those for sure. We definitely want our constructor function. And we definitely want some kind of public functions, or in our case, some kind of public override. Overrides. There we go. Public overrides. So let's do these three for now. Okay, so the first thing is, let's think about our constructor. I start with a constructor. And I start with the empty constructor just for now. And I want to think about what my contact class will need. Well, I'm probably going to need something like a full name, a contact number, and an email address. Yeah, those things. And that means I need a full name, contact number, and email address, public property. Let's do that now with getters and setters. So get full name. I'm going to return this .m underscore full name. And you're going to be, wait, what? We don't have a full name. When you use it, it gets created. I know I'm laughing at that, but it's true. And then we can set full name. And we can set something in there, like full name. And we can say that this full name, right? And we can do it right. So it's m underscore full name to keep that same structure is equal to full name. And once I have this, I can say that, hey, this full name is equal to full name. So this, which is a property, is going to be assigned to the value that I get from full name, which is a parameter. Okay, I want to do the same thing for the other two. So copy paste. So notice how it doesn't give us an error. Look at that. No errors in our Visual Studio Code. Again, bad tooling, right? So we don't know what it is. So let's put in, instead of full name, it's going to be contact number. And it doesn't tell us. We don't care. It doesn't care if these are mismatching. None of that. Who cares? It'll serve meat to vegetarians. No problem if you let it, right? Does whatever the boss says. That's you. You're the boss. And this is contact number. And that's a terrible thing to do. You should always, give people what they want. So same thing with us. We want this to be contact number. By the way, this is not a Visual Studio Code problem. This is a JavaScript problem, which I'm defining for you. Last one is we can do that here, so we can update that. We can say this dot contact number is equal to contact number. Notice the difference when I hover over one or the other, right? I can hover over one, it tells me it's a property, and the other one is a parameter. Which is pretty cool. It detects that. One last thing. Let's do the one for email address. No complaints. There's email address. We're just copy pasting so we can save some time. And then m underscore email address using kind of m underscore plus camel case. And this should be email address. Nice. Excellent. And now we can finish this off, the constructor. And you can see that it all adds up. Questions around this? Why did I do getters and setters when all I needed was this? I didn't have to do getters and setters. I could have just done this. Full name, contact number, email address. Done. Constructor done. And all of this would have been done too. Because getters and setters give me options, right? Getters and setters are the representatives. They're kind of the ambassadors of my private instance members. Now, in this case, my instance members are not private. They're not private, but it doesn't mean that I should treat them any differently, right? So I'm going to store my data in the anything that says underscore, but I want the user to use my getters and my setters to connect with me. One, variable, contact number, full name, or email address. Okay, that's what I want them to do. Finally, our public override. Cooper says, any idea what theme extension is giving you the white font for properties? I don't know. It could be ES6. Let's see if there is something like that I have in here. So I have a JavaScript ES6 code snippets that might do it. That's probably what it is, this one. That gives me that code hinting. It could be, but I doubt it. But don't worry about it. It's just a theme, and you could look up other ways of doing something. I mean, again, to me, it seems somewhat helpful, but it doesn't matter. Here's something else that I want to do. I want to do a public override. Let's do a public override. And remember, all functions, all objects that you create, all classes, have the object superclass as its base, right? Which means all of them have a toString method we can override. So we can override the toString method. So we can return a template string. We can say something like full name. And that would be, we can use interpolation, where you can say this dot full name, right? And then \n. And let's just do a space for now so I can show you what this looks like. And then full name, and then contact number. \n is new line character, right? And we want to use, again, interpolation. And then finally, yeah, okay. And that is your string. Okay, so full name, contact number, email address, and I've overridden the toString method that's built into all objects. Okay, that is my contact class. Are you with me? Check mark if you're with me, X if you're not. I got some check marks. Mostly check marks. Thank you for that. Good. And a thumbs up too. All right, so what does this all mean? Thank you for that feedback. So now that we've created our class, can I use it? Can I use the class the way it is right now, my files? Eden says no. Anur says no. And those are the right answers. No, I cannot. The only way I can use my class is if I attach it to some kind of HTML document. That's the first step. So first step is you make your class. Number two, now that I have my class, attach it. Let's put it only on my index.html for today. So index.html, click onto it. At the bottom, what I want to do with my own classes is I want to put them in reverse use order. So I typically, this is just my own paranoia. You don't need to do this, but I'd like to do it. I want to introduce the class before I use it. So example, if I'm going to use it in my app.js file, I wanted to introduce it here. So I will put in script, source, and then /scripts/contact.js. Contact is my new contact class. Now I have access to it. Cool. Excellent. Let's check and see what this looks like just by doing this inside of my in my browser. So again, control backtick, and let's launch another terminal, and I'll just do light server, and let's see what that looks like. All right, so there's my browser, and if I look inside of it, if I do an inspect, then you can see in the console that I got my home page, which is good. And in my browser, I can do something that looks like this. Try this, guys. Let, and then your name, or we'll make a random name like Daryl, right? Daryl is equal to a new contact, and it's asking me for full name, contact number, and email address, and it says that's a function. That's what that F is. Full name is Daryl. Let's say Daryl Olson. And my contact number is also a string. So let's say 555-555-5555. And followed by their email address. Okay, there we go. And enter. And guys, I added a contact on my console. And now you might say, this is cool, Tom. No, it's not cool. I should not be able to do this. I should not have access to variables or classes in my console unless that's what I want. This was not on purpose. This was an accident, all right? And there should not be any accidental exposure to classes and objects. Now, if I do something like this, console.log, I can do something like Daryl.toString. And it will do me this, right? And notice that it gives me everything, but they're slightly offset. We're going to fix this in a second. Neat. You can put your own name there. And this is not what we want. Okay, we don't want this ever to happen. In order for us to prevent this from happening, we're going to encapsulate this contact inside of our inside of a namespace. Not today, but we're going to do it on Friday. For today, I want to do this exact thing, but inside of my code. Let's do that. So going back to my code in my app.js, right? First of all, you know what? Before we do that, let's put this up on GitHub because we just added a contact, and it's good practice to do something like that. So we'll say git add dot, git commit -m, and we'll say added contact class. And then git push, okay? And push that to GitHub. Yay! GitHub is now updated, and this is all good. Now, what we want to do is I want to add, this test to my app.js. Let's do that. So down here, just before the my display homepage function ends, for me it's around line 39. It could be somewhere else for you. I want to test it. So let's test our new contact class. How do we do that? We're going to say let, and we'll just say Daryl again. So Daryl equal to a new contact. And inside there, it'll tell me full name. But look like full name is of type any. Remember, it doesn't know that full name is a string. Contact number is a string. Email address is a string. It doesn't know anything. It knows that I'm going to output a contact. That's what it knows. But the types in here, it doesn't know anything about. Okay, cool. So let's do that. So new contact. And we're going to say this is Daryl Olson. You can put whatever name you want, plus a phone number, and then an email address. Okay, there we go. And now that we've created Daryl, it's grayed out. But let's do something with Daryl. We'll see a console log, and we'll say Daryl.toString. Okay. And if I do this, save, and if I go back to my browser, you're going to see that it's there. But it's offset. How do I fix that? Well, that's in the contact. In the contact class, what I did was I added spaces after the backslash. Let's take those spaces away. It was just easier to type this so you understand what I'm doing. So if I press save now and I go back, you can see that they're aligned. And if I want to space this out so that the colon is aligned, I think it's like 5 spaces. So it's like 1, 2, 3, 4, 5. Let's do that. So let's move this colon 5 spaces, right? And save. And now you can see that those two things are aligned. And the email address can move 1 space. And that's aligned too. So that is our toString method that outputs the information about our contact. And that's where I want to stop today. Okay. Let's put that up on GitHub. So I'll say that clear git add dot git commit -m, and I'll say test passed for contact class. I mean, not really, but I made a little test for contact class in my app.js, and Git Push. Done. So that's it for today. Any questions around, making a kind of a class in ECMAScript 2015, 2016, 2017, and so on? That's how you do it. Okay. And by the way, if you ever want to compare my code with your code, we could simply go to github.com/Durham Programmer, and you can always look up the stuff we just did. So here's the link. I'll put it on YouTube as well, and on here, right on the chat. So that's if yours is not working exactly like mine, well, you can take a look at in-class exercise 3 by going in here and taking a look at the files that have changed. By the way, one great way of looking at all these things is if I go to my commits, they're broken down by week. So you can clearly see what I've done, right? So this is like day 1, we started coding, day 2, day 3, and this is day 4, right? Where I added some stuff, right? Each day is listed, and those are the days that we did stuff. Okay, so pretty simple, straightforward. Right, and this is where I added project files for ICE3, and I got 3 commits for this ICE. That's why I always do this kind of thing, where I say added files for whatever the ICE is, right? So this is where ICE2 started, and you can see that ICE2, I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 commits for ICE2. And for ICE3, I've got 3 commits right now, and I'm probably going to do a lot more on Friday. Okay, so that's how you can check for yourself. And if there's no questions, I'm going to go to here and go back to our summary. So today we talked about ECMAScript 6 functions a little bit. We talked about what ECMAScript is, and a little bit of a history of JavaScript. We're not doing that again, right? But it's pretty straightforward in terms of the stuff that we're doing. Okay, so yes, I did do that, Matt. I'm going to talk about that in a second. Cooper says, to upload to GitHub pages, we overwrite the node modules, correct? Yes. Yep, just keep the .git folder, exactly. Okay. All right, so that's it for today. We'll meet again on Friday, and we'll do the rest. And again, we have quite a bit to do still. We've done pretty much all of this, right? And we need to do this part, and this part's going to take 2 hours for sure, 100%, right? Why? Making this contact list, we need to make a page, and we need to make it interactive and work. We need to store our contacts in our local storage and session storage, plus modify our contact class so that it is in a closure. So lots of work still to do by Friday, and I'll produce that lab report for you guys so you can do your in-class exercise by then. All right, guys, I'm going to stop recording on YouTube, and then I'm going to take questions in the class. All right, so I had a question.